This is an interesting site because what it allows you to do is to see the, let's pull this back open. You get to see the relationship between the unit circle, which is over here on the left, and what the sine function actually graphs out to on the right. So what I'm going to do is, by pushing this plus sign, okay, I am marking out on the left side on the unit circle, and this red line is the height, which corresponds to the sine value. So by marking out the height, this height will be the same height over here. The angle theta, which is placed down here, will be the same angle over on this axis. So notice that as I get to 90 degrees, I'm at a height of 1. Now as I pull closer to 180, my height value decreases, so I should drop. As I pass 180, my height value is negative, so I'm going to be below the axis, increasing until I hit 270 or 3 pi over 2. And then I'm going to increase as I go back up to 2 pi. And of course this will continue. So again, we can mark this back out. We'll just let it draw this time. And you can see on the left side, on the left side we're marking out over the unit circle, and on the right side, that red line on the left side is matching the red line on the right side. And you can see how, as we mark along the unit circle, we're graphing our curve out. Now the same thing is true for cosine, so let's take a look at the cosine function. Now the difference with cosine is we're measuring left and right. So what I'm going to do is rotate this guy. Now cosine starts at a height of 1, but since we're measuring left to right, let me rotate again. Let's go back to 0. So I'm measuring all the way to the right, so our height value is the cosine value. So y is height, the x value falls along this axis, we just happen to be rotated. Okay, so here's our x-axis, but we're measuring distance across now. So we're going to start out at 1 because our distance across is 1. As we hit 90 degrees, we're no longer moving left or right. So our height value is 0. Our left-right movement is 0 here, so our height value of our function is 0 here. Now, of course, as we move into quadrants 2 and 4, we're negative, and when we hit 180 degrees, we're at a height value of negative 1. So we start out, let's go back here, we start out at a height of 1 because that's our left-right movement. So really what we're doing is we're looking this way, left-right, okay, this is left-right, but it's being drawn out here on this. And so our left-right movement goes to 0, and then it goes to negative 1. So now at 180 degrees, we're fully to the left, so our cosine value is negative 1. As we start coming closer down here to 270 degrees, we start becoming more positive because we're measuring this little red line right here. And once we hit 270 degrees, we're at a height of 0, which is why our graph should be at a height of 0 here. And once we hit 360 degrees, we're at a left-right movement of positive 1. So we should be at a height here of positive 1. So let's just do this one more time. We'll recap it. So our left-right movement here is 1, which means we should be at a height of 1 since y, our height, is equal to the cosine value. So cosine measures left-right, so our height will be whatever our left-right movement is. Now, as our left-right movement starts to shrink back to 0 at 90 degrees, at 90 degrees we have no left-right movement, which means we should have no height on our curve. As we keep going, our left movement increases until we hit at 180 degrees, and then it should be at negative 1. So since our left-right movement is negative 1, our function should be at a height of -1. So this function gives the height value equal to the left-right movement value. As we increase, okay, our left-right movement goes to 0 at 270, so our height should be 0. And of course, at 360, we've now completed one period of the function, and we're back up at a height of a value of 1.